Okay, welcome back. We stopped at alkane as homologous series. And we said that you can obtain alkane using what? General formula of CnH2n plus what? 2, in which we did and we obtained this. Now, for us not to waste time to calculate this in the formula, you can as well what? Add CH2 and get the other members of the alkane easily. If you do that, you will know that it will save your time and stress. So the next homolog for homologous series of alkane is what? Is called butane. So butane will give us a molecular formula of what? C4H what? H10. Followed by propane. Propane is C6H what? H12. This one is more easier. Next is, after propane, methane, ethane, propane, butane, pentane. Not propane again, pentane. Then you have hexane. Hexane is C8H what? 14. You have heptane. Number 7 is heptane, which you have C9H16. Then you have octane. Follows, you just add CH2, which is C10, C8H18. Then you have nonane, the 9th member, C9H20. Then they have decane, which is C10H22. So this is an example of an homologous series, alkane. And all of this from methane to decane are called homolog. And this is how to derive their words, their molecular formula. You can as well draw their structures. And these are under what? Saturated hydrocarbon with only single bond within their carbon chain. For example, I will draw only 2. Let's pick the butane. For example, butane will give us C, 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 C. We have 4 carbon atoms. Then each of the carbon atoms will contain what? Will contain hydrogen what? Atom. So this is the structure for butane. You can as well do same for any of this. Let's say heptane. Heptane will give us 7 carbon atoms with 16 hydrogen atoms, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of this contains single bond with hydrogen atom across board. So that is why we classify them as what? As saturated what? Hydrocarbon. Okay. We have other series like the alkene. We have the alkene, we have the alkynes, we have the alkanols, we have the carboxylic acid. Maybe I should pick one and illustrate. I'll pick only one and illustrate. Let me illustrate that of alkyne. Or let me take 2 of each. Then the alkene, alkene is prepared by using CnH2n. Now, alkene, the first member is not there. There is no methane equivalent for what? For alkene. But we have 18. So 18 is second member. Substitute 2 for n, you have C2H2n times 2. We give us what? We give us C2H4. Are we together? Then the structure of this guy will be, because of the unsaturation, there will be a double bond in between what? The carbon atom. So that will give us what? C double bond to have 1, 2, 3, 4. As you can see. On no account should you add extra hydrogen atom to any of them, because if you do that, you're going to what? Violate the rule of the tetravalency of what? Of carbon atom, in which this carbon will make it what? A wrong structure. So the last H is not advisable to be there. You have just 2 carbon atoms and 4 what? Hydrogen what? Atom. So that is the structure for what? For 18 from Alkene homologous what? Series. All right. Maybe if you go for propene, will be C3H6 followed addition of what? Minus CH2. Then butene will give us C4H what? 8. Now, in the case of butene, we have what we call the isomers. Okay, we have what we call but1 in and but2 in. So the structure of butene will change. Will give us two structures. Let's draw for that butene. We have C, C, C. Now, is it but1 in? If it's but1 in, the functional group is attached to what? The first carbon atom. So we can have C4H8. So this is 1, 2, 3, 4, carbon 4. Then we have 1 hydrogen atom. So we still need another atom here to make it what? 4. 1, 2, 3, 4. We have 1, 2, 3 bond. So we need another what? Hydrogen atom to make it what? A tetravalence what? Carbon atom. So this is complete. 1, 2, 3, 4 for the first carbon atom. We also have 1, 2, 3, 4 for the second carbon atom. But the rest carbon atom will contain their usual what? Hydrogen what? Atom. So this is a structure for, this one is but1 in, because the functional group is attached to what? Carbon 1. Carbon 1, 2, 3, don't worry, we'll get to these points later. Then the other structure for butene is called but2 in. It's simple. Just exchange this guy to this point. Exchange this to this. This is carbon 1. Move this to carbon 2. You have what? But2 in. That is 1 double bond. That is just the difference. But1 in and then but2 what? In. So others contain what? Their various hydrogen what? Atom. So this is a structure for but2 in as isomer of butene and so on. So just continue the rest till you get to the alkene. Keep on adding CH2 to this and you will have the formulas of the respective homolog under Alkene homologous what? Series. Okay, I'll only illustrate the first 2 of the Alkyne because they are too numerous. I can't finish it. Now, just the first 2 for the Alkyne. Alkyne is CnH2n minus 2. Minus 2. And it contains triple bond between their what? Their carbon chain. Now, there is no methyl equivalence for Alkyne. So we have ethyl or we have ethane equivalent, which is called ethyne. So ethyne can be obtained. Ethyne can be obtained. Use this. We have C2H2 times 2 minus 2. That will give us C2, okay? 2 times 2 is 4. Then 4 minus 2 again will give us what? 2. So this is the formula for what? Ethyne. How do we get the structure of ethyne? Just 2 carbon atoms with 2 what? Hydrogen atom. Because of what? The triple bond in between the carbon atom. We have 1, 2, 3. So we need only one carbon at only one bond to complete the tetravalence nature of carbon here. Likewise, the second carbon atom. So that's why you have C2H2. So H is here, H is here. So this is a structure for what? Ethyne, gotten from this formula. Okay, maybe the next one is protein. But protein will give us an isomer. We do the same thing. Okay, add CH2 to this. That will give us what? C3H4. C3H4. What is the structure? Structure will be like carbon atom is still here. We have 3 carbon atoms. Don't forget that this must be in one of the carbons. 1, 2, 3. 1, 2, 3 carbon. It's complete. Now let's check how we can do what? Spread H across the 3 carbon atom. So let's start with this, simplest. So this is settled. We have 1, 2, 3, 4 bond to the first carbon atom. Here we have 1, 2, 3, 4. So this carbon atom, there is no need to attach hydrogen atom to the second carbon atom, because if you do that, it will give us what? 5, which is wrong. So transfer the other hydrogen atom to the last carbon atom. You have H, H, and H. So this is the structure for what? For protein. This is prop2-ine. The real alipag name is called prop1-ine. Okay, so if you continue forward, you will see that you get to the decyne by adding what? CH2 to the first formula. You get down to all the formulas of the homolog contained in the alkyne group. The same thing goes to alkanol, goes to carboxylic acid, goes to alkanal, and so on and so forth. Okay, let's proceed from our slide. The simplest series is the Alkene, which we have done that, with general molecular formula of CnH2n plus 2, where n is what? Is a whole number with a value of 1 or more. We have done that already. Other homologous series include the Alkene, which is gotten from CnH2n, Alkyne CnH2n minus 2, which is on the board. Then alkanols, CnH2n plus 1 OH. Then alkanoic acid, or they call them what? Carboxylic acid. We can obtain the homologs from CnH2n plus 1, then COOH. Now, all these are their functional groups that shows that they belong to a particular what? Homologous series. Okay, then what is functional group? A functional group is an atom, a radical, or a bond common to a homologous series, and which determines the main chemical properties of the series. Now, this is what really indicates that a particular organic compound belongs to a particular what? Homologous series, based on their functional group present. It can be an atom, it can be a bond, it can be what? A radical. Now, each functional group has its own characteristic properties. Like the alkene, because of the double bond, they have special properties. The alkyne, because of their triple bond, they have their variable properties. Then the alkanals, then the carboxylic acid, they have their what? Their various what? Characteristic properties, because of what? The presence of functional group. Functional group determines the chemical properties of any organic compound. Okay, the alkyl group. Now, without the alkyl group, organic compound is not complete, because they are grouped together. Now, the alkyl group are gotten from the alkane family. For example, this is our alkane. Let's take the first one, methyl, for example. Sorry, methane, for example, which is CH4. This is the normal hydrocarbon, methane, that belongs to what? Alkane homologous series. Now, for us to get the alkyl group of it, you do what? You reduce one of the hydrogen atom from the methane by 1. That will give us what? CH3. So this, okay, becomes our methyl group. So this methyl group now is called what? The alkyl group. So every hydrocarbon contains what we call the alkyl what? Group. Methane, CH4, the methyl, CH3. Methyl is gotten from where? From methane. By what? Reducing one hydrogen atom, and you have -CH3. So this is a methyl example of what? Of an alkyl group. Okay, this includes all the valence group derived from the alkanes by the loss of hydrogen atom. Alkyl group has general formula of CnH2n plus 1 and is named after the parent alkanes by replacing the ending N by YL, as you have seen on the board. Methane, this one is being replaced by what? YL, methane, methyl. This is alkyl, this is alkene, this is what? Alkyl what? Group. Okay, let's go for a brief break. When we come back, we continue from there. Thank you.